This is number 21 from the homework, and this is the reaction. So silicon dioxide plus 6 moles of hydrofluoric acid yields, I don't know, whatever this thing is. What do they call it? Hexafluorosililic acid, all right, and 2 waters. And the first thing it wants to know is, what is the limiting reactant? So, it tells us more, that there are 40 grams of silicon dioxide and 40 grams of hydrofluoric acid. So, A, on the homework, what is the limiting reactant? So I need to convert grams of silicon dioxide to moles of silicon dioxide to moles of this compound, because it asks about that in a subsequent question. Remember, I gave you a pointer. I said, look ahead in the questions to see which product you should choose, and then I need to go to grams of hexafluorosilicic acid. So let's start with 40.0 grams of SiO2 times, and then it is 1 mole of SiO2 for every 60.09 grams of SiO2 times, and then it is a 1-to-1 ratio, so it is going to be 1 mole of H2SiF6 for every 1 mole of SiO2 times, and then we will go to grams, and it is 1 mole of H2SiF6 for every, let's see, I added up. The silicon is 28.09, the 2 hydrogens would be 2.016, and 6 of the fluorines gets you 144.106 grams. And then if I multiply that across, we would get you work it out, I'll work it out, and we'll compare our answers. 40.0 I got 95.9, and then 3 sig figs, yeah, that'd be right. So 95.9 grams of H2SiF6. All right, so that's for one of my reactants. Let's go for the other reactant. The other reactant is our hydrofluoric acid. And so we also have 40 grams of that guy. So 40.0 grams of hydrofluoric acid times, and it is 1 mole of hydrofluoric acid for every, let's see, 1920, so it'd be 20.008 grams of hydrofluoric acid is 1 mole, times then it is a 6-to-1 ratio, so it is 1 mole of H2SiF6 for every 6 moles of hydrofluoric acid, times then, same deal, 144.106 grams of that compound for every 1 mole of that compound. And that's going to equal, I'm betting that's going to be a lot smaller. Yeah, because that's like 2 times, that's going to be a third. And so that's only going to come out to be like 20-something grams. So 40. Yeah, 48. Is that right? 48? Yeah, because a third of that would, let's say 150. Yeah, so 48.0 for 3 sig figs, 48.0 grams of our hexafluorosililic acid stuff. All right, so this is my limiting reactant. And this is going to be the excess. All right, so that's A, and then now I got to clean the board so that we can work out B and C. All right, so part B of our question said, what is the mass of excess reactant? And then I'm going to read that since, well, man, I should have typed it better in the first place. What is the mass of excess reactant that remains after the reaction is complete? So we found in part A that we are going to produce, so there is going to be made 48.0 grams of that compound. And that is going to completely exhaust the hydrofluoric acid. So at the end, there will be 48.0 grams of H2SiF6. And at the end, there will be 0 grams of hydrofluoric acid. All right, because that's the limiting reactant, so we're going to use absolutely all of it to make that quantity of H2SiF6. But how much of our excess reactant, the SiO2, will remain? So it's not going to be 40 because we're going to take a chunk out of that 40. So that's what we need to figure out, is how much SiO2 will have to be used in order to make 48.0 grams of H2SiF6. So we are going to then do some stoichiometry back to the SiO2. So it's going to be 48.0 grams of H2SiF6 times, and we had it up there a moment ago, it is 1 mole of that guy for every 144.106 grams times, and then it is 1 mole of SiO2 for every 1 mole of H2SiF6, and then we'll want to convert that to grams, and so we had found earlier that it is 60.09 grams of SiO2 for every 1 mole of SiO2. And moles of SiO2 divide away, moles of H2 SiF6 divide away, and grams of H2SiF6 divide away. So we got 48 times 60 divided by 144, and that comes out to be 20.01, and so for 3 sig figs, that gives us 20.0 grams of SiO2, and that is used. We're going to use up 20.0, and if I want to know how much remains at the very end, it would be my original 40, so that was my initial amount, minus the amount that I use, which is 20.0 grams. And so at the end, remaining would be 20.0 grams. So that would be our answer to part B of this question. 20.0 grams of SiO2 remain after the reaction has reached completion. Now, 21 part C says, what is the theoretical yield of H2SiF6? And so back in the question, it told us that actually produced was 45.8 grams of H2SiF6. And we found that the theoretical yield earlier, back in part A, was 48.0 grams. So this is our theoretical yield. From the question, it told us that 45.8 grams were actually obtained. And so 45.8 divided by our theoretical yield of 48.0, well, that was a pretty darn good reaction. And then we're going to take that times 100, right? Because that's how you turn a fraction into a percentage. And so 45.8 divided by 48 equals, and then to 3 sig figs, that would be 95.4%. So there you go. There is number 21 all worked out for you. Hope that helps.